Good morning. Today I'll explain. This is a Nandini physics tutorial for IIT JAM, GATE and csir net. So today our topic is atomic and molecular spectroscopy. So in previous lecture 14, I think this is a lecture 14. In lecture 14 I explained normal Gman effect. So in the normal Gman effect I got this Gman shift. This is called nothing but Gman shift, and this is called Lorentz number of Gman shift. This is the frequency, shift frequency, okay, delta nu. So once again I recall all these things, and we will draw a triplet to triplet transition through using this Gman effect. Okay. So first of all I will write the selection rules here. What is the selection rules? So selection rules. So selection rules. Okay. See, for normal Gman effect. So selection rule for normal Gman effect. See, delta ml is equal to 0 plus or minus 1. So this is about the selection rule, and this is nothing but normal Gman effect selection rule, and it is also called as magnetic dipole moment. Okay. And see, for delta ml is equal to 0 for which type of polarization? This is called pi polarization, because in I already explained when a silver at Gman effect experimental proof, in that experimental proof they placed a silver atoms. Okay. Because if you see the longitudinal view and transverse views, and longitudinal view it look like a circular polarization, in transverse view it look like a linear polarization. In linear polarization we will get the selection rules. That selection rule, delta ml value is 0 plus or minus, this is nothing but magnetic dipole moment exists. So when delta ml is equal to pi means it is a pi polarization, and delta ml is equal to plus or minus 1, this is given sigma polarization. Okay, sigma polarization. So this is about actually selection rules. Okay. So based on the selection rules you can draw any patterns, like singlet to singlet transition is possible by using this selection rules. Okay. Once again I see the shift. Once again I write the shift, whatever the shift I explained in the last session or the last class, that split once again I will write here. See, what is the Gman shift? We will get Gman shift. So that Gman shift is nothing but, see, Gman shift. Once again I write Gman shift. So this Gman shift is nothing but delta nu is equal to EB by 4 pi MC. Okay. So how you will get this? This is nothing but actually mu naught B. Actually this is nothing but mu naught B divided by CH only. Okay. So you will write mu B is nothing but EH cross by 2m. So this is called Bohr Magneton. So using this Bohr Magneton, I will substitute Bohr Magneton. Mu B is equal to EH cross by 2m, where H cross is equal to H by 4 pi. So finally you get this value. So therefore delta nu is equal to, so what about this value? This value is nothing but 46.7 meter inverse into capital B. So this is nothing but Lorentz number. So this value is called Lorentz number. Okay. So this is about magnetic shift. So Gman shift we already derived in previous class. Okay. So this is about, so but when you will write this Gman shift in terms of wavelength, how you will write in terms of wavelength? So note point. So in terms of wavelength, So in terms of wavelength means nu is equal to 1 by lambda. So simply write. So differentiate both sides, delta nu is equal to minus 1 by lambda square into d delta lambda, okay, d lambda. So therefore take modulus delta lambda is equal to 1 by lambda square into delta mod, okay. So therefore you have to substitute what is the delta nu, so delta lambda in terms of wavelength means delta nu is represented as delta lambda into E by 4 pi mc into, okay, capital B into what is the value into lambda square, because lambda square into delta nu, okay. So this is the value of Gman shift in terms of wavelength. So this is very important for problems it is very important, okay. So Raman shift in terms of wavelength, and this is the Raman shift in terms of frequency. So this is called Raman shift, Gman, I'll always take Raman. So Gman shift in terms of frequency and Gman shift in terms of wavelength, okay. So next, what is actually features of normal Gman effect? I will explain what are the features of normal Gman effect, okay. So this is about wavelength and selection rules and in terms of wavelength of Gman effect. So right now I explain features of normal Gman effect, okay. Features of normal Gman effect. So features of normal Gman. So what the features you will get the normal Gman effect, I will write once again that features here already. So in normal Gman effect is possible only when S is equal to 0. So it is possible only when S is equal to 0. So only when S is equal to 0 means what is the total angular momentum? J is equal to L only, okay. And what is Landis factor? Gi is equal to 1 plus J into J plus 1 minus L into L plus 1 minus S into S plus 1 divided by 2J into J plus 1. So this is the Landis factor, okay. So but it is possible only when S is equal to 0, when J is equal to L means this value will become 0, okay. So therefore Gi is always equal to 1 only. So from both initial and final states having same Gi values, Landis effect, then only this normal Gman effect will be existing. So this is one of the important point in the Landis factor is always same for both initial and final states, okay. So that means Gi is equal to Zf. So in this condition only normal Gman effect will be existing, okay. And what are the total possible values of normal Gman effect? That is called 2L plus 1. So total number of possible values are 2L plus 1, okay. This ink is sticky. So total possible values of normal Gman effect is 2L plus 1. So this is called possible values of normal Gman effect. So let us see one example, okay. So normal Gman possible values are level also, you can call it is a total number of level, okay, 2L plus 1. So what, first of all I explain the transition, one problem is there. See the problem, transition from 1p1 to 1s0, okay. So if you see this transition in normal Gman effect, actually in Gman effect it will be splitting, okay. See P will be split into 3 ways and S is 0 and J is nothing but 0. So there is no split, only if J is equal to 1. So if L is equal, J is equal to 1 means, see here L is equal to J means total 2 plus 1, 3 states. So this will be three states will be there, because the degeneration, this is nothing but degenerate state. So this is called degenerate. Okay, so due to, if L is equal to 1 means, so what about J value is equal to L, that is equal to, here what is the J value? J is equal to 1, because if J is equal to 1 means it is L is equal to 1. So therefore 2 into 1 plus 1, you will get 2 plus 1, total 3. And now the P will be split into 3 parts. Okay, and take S is equal to 0, J is equal to 0 and L is equal to 0. So therefore 2 into 0 plus 1, so therefore 1. So it will be split into 1 part. So therefore, due to, if you want to draw the Gman shift or Gman pattern of 1sp, 1p1 to 1sp1, the splitting is only possible when its multiplicity is 1. So it's one condition. How you can say that? How you can say that multiplicity 1 only exists in normal Gman effect means already spin is 0 means multiplicity is 2 plus 1 is nothing but multiplicity. Okay, so if 2 is equal to 0 plus S is equal to 0 plus 1 is nothing but multiplicity 1. So the multiplicity is 1, nothing but this transition is allowed only when multiplicity is 1, and the transistor after that the level if this transition will be possible when S is equal to 0. So this is called a single electron transition, electron to electron transition. It is not many electron to many electron transistor. Many electron to many electron transistor will be possible in anomalous Gman effect. Understand? So this is a normal Gman effect I explained. So if you see the 1s naught, if you see, so this was not splitting. So simply take, this is only a 1s naught value. Okay, where this is a not split, but the P level will be splitting into 3 possible ways. Okay, so this is nothing but 3 possible ways. Okay, so that is P is nothing but P state means, see what are the possible ML values, either 1, 0, minus 1, because ML values are possible from minus 1 to plus 1. So that is nothing but minus L to plus L. So that is nothing but 1 comma 0 comma minus 1. So this will be splitting into 3 levels. So L is equal to 1, J is equal to 1. Okay, so this is called L is equal to 0 and S is equal to 0 case. So that's why it was not split. This is S state. Okay, so the transaction is possible. See 0, because what is the selection rules? I already write the selection rules. Delta ML is equal to 0 comma plus or minus. This is the selection rules for normal Gman effect. See 0 to 0 is possible, okay, because it is a 0 to 0. Okay, no need to write here, it is a simply 0 state. Why? Because J is 0. Okay, so 0 to 0 is possible. This is called delta ML is equal to 0 transition. And see minus 1 to 0, minus 1 minus 0, changing. Okay, changing states are nothing but delta M, minus 1 minus 0. So this is nothing but one possibility. And see, this is plus 1 minus 0. This is another one possibility. This is called delta ML plus 1 and this is delta ML minus 1. So this is the possible. Right now we can specify this transition into, so this is a pi polarization and this is a sigma polarization, So this is the triplet to triplet transition. Okay, so singlet, singlet transition, singlet, singlet. You can see another more second example when D state to P state. P state will be splitting into 3 parts and D state will be splitting into 5 parts. Why? Because ML value, possible values are ML values are minus 2 to plus 2. Similarly, P state minus 1 to plus 1. Okay. So if you see the block diagram of see the same configuration and same spectral term into 1D2 to 1P1. Okay. So in this state, the P state, this is a P state and this is a D state, and D state P is equal to, in P state L is equal to 1, J is equal to L. So therefore J is equal to L is nothing but only 1, and D state also L is equal to J and J is equal to 2 only. Why? Because states are same. See, but this state is splitting into, because degenerative, because J value is equal to 2 means total number of values, the possible values of L is equal to, see here 2L plus 1, 2L plus 1 means 2 into 2, 4, 4 plus 1, 5. So therefore this is splitting into 5 parts, first one, second one, third, 4, 5. So, this is the 5 parts, and this is a splitting into 3 parts. So, this is the 3 parts, minus 1, 0, 1, minus 2, minus 1, 0, 1, 2. So, the possible values of ml values are nothing but, see, first of all, delta ml is equal to 0 value, take 0. So, 0 to 0 is possible, and see 1 to minus 1 is possible, okay, and 2 to 2, 0, only 0 possibilities are there. See, minus 1, no? Minus of minus, no, 0 to 0 possible, 1 minus 1 possible, only 2 values, remaining will get minus 1 plus 1, okay, minus 1 plus 1, minus of minus plus, minus of minus plus 1. So, you will possible here also. So, this is the value, okay. So, 0 0 plausible, sorry, you will get minus 1 plus 1 possible. So, this is a delta ml is equal to 0 value. Similarly, minus 1 you will get minus 1, minus 2 minus of minus plus 1, you will get one transition here, and see minus 1 0, you will get here one transition, and you will get one transition here. So, this is called delta ml minus 1. Similarly, delta ml plus 1. So, therefore, you can write that this is the sigma transition, okay, and this is the pi transition. So, this is the Gman transitions. So, Gman pattern of d state to p state for singlet electrons. For single electron to single electron transition only possible when normal Gman effect. So, don't need multiple electrons transition was not possible in normal Gman effect. So, right now come to in the case of, see, how to identify is very important. So, in the how to identify it is Gman effect, or it behaves normal Gman effect, it behaves anomalous Gman effect. I can explain the chart in the next session. Okay, so, using that chart you can identify the transition is allowed on the basis of normal Gman effect or on the basis of anomalous Gman effect, you can understand. Okay, by using by the help of that chart you can specify the state also. Okay, so this is about a normal Gman effect. So, right now I will move to anomalous Gman effect. So, anomalous Gman effect means the spin is never becomes 0, the spin is not equal to 0, there is a spin state is also there. So, in presence of spin state, similarly normal Gman effect I will explain in the same way, I will explain the anomalous Gman effect also. So, it is also you will get something value. So, right, next anomalous Gman effect. So, in anomalous Gman effect, see, actually a electron revolving around the nucleus, this is the electron nucleus revolving around the nucleus with sufficient velocity v. Okay. See here in anomalous Gman effect, see S is not equal to 0. So, therefore, J is equal to L plus S only. Why? Because according to spin orbit interaction, the total angular momentum L is equal to angular momentum L plus a spin momentum. Okay, angular momentum plus spin momentum, that is called total angular momentum. So, therefore, this electron oriented around this fixed orbit will gives a orbital motion, that orbital motion L, and it provides some magnetic momentum, that is called mu L. Okay, and similarly there is a spin is also there due to its own rotation, due to electron own spinning, own rotation, with the help of axis is create some spin magnetic momentum S, and its spin quantum number S, and it provides a spin magnetic moment mu S. Okay. So, these magnetic moment will always opposes this quantum numbers, opposes this number. Okay. And see, because internally there is a one magnetic field is developed. So, interaction of this magnetic field, internal magnetic field plus interaction of this magnetic moment will gives a spin orbit interaction, understand. So, right now I will introduce this atom into external magnetic field B external. So right now this B is interacted with external magnetic field interacted with the combined spin magnetic moment as well as orbital magnetic moment. So this interaction, so this called interaction. So interact these external magnetic field as well as mu s. So therefore the magnetic momentum mu L into mu s is equal to nothing but mu j. So what you will get? Total magnetic momentum. So therefore what about the interaction energy? Interaction energy is equal to minus Gj, because this is a total magnetic momentum, and the Landé G factor for magnetic momentum is Gj into C. No need to write Gj first. Interaction energy I will write. Interaction energy is minus mu j dot capital B. So this is called external magnetic field into this is called magnetic momentum. Interact with magnetic momentum with this external magnetic field provides interaction energy. Okay, so that interaction energy I can write the expectations of what is the magnetic momentum? Mu j is nothing but minus Gj, okay, E by 2m into J. So simply substitute, you will get interacted energy, that is called Hamiltonian perturbed energy. Why? Because we want to find out the correction also. So that is the reason I take the expectation values of H bar, because this is called perturbed Hamiltonian. So therefore this energy is equal to mu j is nothing but Gj E by 2m into j into b. So I want to find out, so this is called Gj E by 2m into what is j? J is nothing but this is a dot product, so simply write jb cos theta. Okay, you will consider the L components of cos theta value by using Z components direction. So this is a magnetic B external magnetic field, and this is the total angular momentum J precession about this own axis. So therefore you will get this is the Z components of J. So L, so this is nothing but Z components of J, and you will, this is the theta. According to the theta is the oriented angle. So now the total angular momentum is precession about this external magnetic field with the theta orientation, and this is the Z components of magnetic field. So this is a Z component of magnetic field. So therefore from this figure, what is cos theta is nothing but Jz by mod Zz. Okay, why? Because the angle of orientation is nothing but Jz divided by Z. So simply substitute this into this equation, then that Hamiltonian interaction energy by using quantum mechanics, C is equal to Gj divided by 2 e power m into C j b. What is the cos theta? Jz divided by j. So mod j is nothing but j. Jj will be cancelled. You will get expectation H is equal to, because this is called expectation is nothing but changing energy delta E. This is the shift energy by relativistic correction. Shift energy by relativistic correction is called expectation H value. So expectation means Z expectation. So Gj by E by 2m into expectation Jz. So what is the expectation Jz value? So this is delta E is equal to Gj E by 2m B into this is called mj h cross. So expectation J Z is equal to mj h cross. So therefore delta E is equal to Zj E by 2m mj h cross into B. So simply write delta E is equal to Ej, okay, into what is E h cross by 2m, and simply take this mj is in front, h cross into B. So this is called Bohr Magneton. So delta is equal to Gj mj into mu B into B. So this is the relativistic correction, first order correction of anomalous Gman effect. So this is the correction of anomalous Gman effect. Understand? So right now I want to draw the frequency. So I want to derive the frequency or maybe in wavelength. I want to find out wavelength, corresponding wavelength shift or frequency. That is, frequency is nothing but I want to find out changing frequency from one state to another state. When electron jump from one state to another state, they may be emit some photon energy. So this is nothing but, nu is nothing but frequency of photon. So I want to find out the frequency of shift. So I want to find out the frequency shift right now. So I will get interaction energy delta E is equal to Gj Mj mu b. So this is also come from under quantum mechanics theory. Okay. So right now I want to find out the shift. See, shift means generally. So this is actually initial and final energy shift. I want to find out energy shift. So I already derived energy shift. Right now using diagram I will prove this theory. So this is energy, this is the initial state and this is the final state. Now what is the energy of initial state is E naught I, E naught F. So electron jump from initial state to final state, it emits a photon energy. What is the frequency? That is nothing but frequency before going to magnetic field. It is not placed in magnetic field. What is that frequency? That is called nu naught. That is nothing but E naught I minus E naught F divided by Ch. So this is called total frequency before applying. Okay. Right. See, say if it is placed in any external magnetic field, see the atom is placed right now B external magnetic field. The atom is placed in B external magnetic field. So B external magnetic field. So what will be happen? So this is right now there may be energy shift exist in this level. So therefore, so this is initial and final state. So simply this is E naught I plus what is that shift? That is the shift Gj Mj of initial state into mu b capital B and E naught F plus Gj Mj F mu b into B. Okay. So what is the energy shift total? I want to find out total frequency of the excited states. So this is nu bar is equal to simply E naught I plus Gj Mj I mu b b, okay, mu b b, okay, plus minus E naught F plus Gj Mj F mu b b divided by Ch. Okay. So you can write this equation into nu bar is equal to epsilon E naught I initial state minus E naught final. This is the ground state Ch plus you can write this term is plus plus E naught. So take the common, you will take what you will get. Okay. So you will take minus plus mu b into b, take common Gj Mj I minus Gj Mj F. Okay. So divided by Ch. So finally you will get this equation. Okay. So finally you will get this equation and we are called as this is already initially ground state before placed in an external magnetic field, the atom frequency nu naught. So this is a new frequency when atom is placed in external magnetic field. So this is old frequency nu naught into Gj Mj I for initial state and Gj Mj final of Ch by of mu b into b by Ch. So this is called energy shift. This is nothing but delta Gj Mj into mu B B by Ch. So this is called delta nu. So this is the new energy shift. So this is called energy shift of anomalous Gman effect. So understand, this is the energy shift anomalous Gman effect. So right now I want to give a small example due to sodium atom. Take a sodium atom Na. In sodium atom, see, the transition is possible when D1 D2 lines. So I want to write first D1 line. D1 is nothing but D1 possibilities are nothing but 2p 1 by 2 2 and multiplicity 2 to s 1 by 2, 2 to s 1 by 2. Similarly, D2 state is represented by 2p 1 by 2 2, 2p 3 by 2, sorry, 3 by 2 2, 2p 1 by 2. Okay, sorry, 2s 1 by 2, 2s 1 by 2. So this is the transition levels. So right now I will explain this transition, and see here also the major condition is the Landis G factor Gi not equal to Gf. See, remember, so the initial Landis factor and final Landis factor is not equal. Okay, and similarly they have levels also are there. The possible values, I will write here all these things. I will explain this thing, okay, in the next class. See, so we will get energy shift as well as we will get energy shift right now. Right now I want to prove Gman pattern for sodium D1 D2 lines. Okay. See, some important features of normal Gman effects. Some features of anomalous Gman effect. So anomalous Gman of features. So the S is not equal to 0 simply. So this is the first feature, spin is never equal to 0 and J is equal to always tells about L plus S only, okay. And so because J is nothing but total angular momentum, that is called spin momentum plus orbital momentum, so that is called L plus S only, okay. And see, the Landis factor Gi is nothing but 1 plus J into J plus 1 minus L into L plus 1 minus S into S plus 1, okay, divided by 2j plus 1, okay. So this value is not equal to 0, because it is not equal to 0, something will be there, but Gi is not equal to Gf. So this is condition, the initial and final states never equal to 0, okay. So the initial and final state never equal, okay. So this is the condition about anomalous Gman effect. One second, I fill the ink. Okay, so this theory was not explained actually. The initial and final values of okay, I fill the what link, right. What I am saying that, so a spin is not equal to 0 and J is equal to L plus S, angular momentum is angular momentum, total angular momentum J is always L plus S only. So Gi is equal to, this is a Landis G factor, and Landis G factor is never equal to 0 in anomalous Gman effect, as well as the initial and final states of the state was never equal to 0. What are the possible values of anomalous Gman effect? The possible the Gman level in anomalous Gman effect is, the anomalous Gman effect level is the level of anomalous Gman, simply you will write here, total level of anomalous Gman effect is 2j plus 1, understand. So, this is also called as degenerate state. Why? Because see, if I am doing the experiment anomalous Gman pattern of sodium light, anomalous Gman effect of sodium. So, what is the sodium lines? D1, D2 lines. Sodium lines are nothing but D1, D2 lines, and see this D1 right now. So, 2p, so the first line is 2p 1 by 2 to 2s 1 by 2, and similarly 2p 3 by 2 to 2s 1 by 2. So, this is the transition. So, take the what is actually S state, see the what is the degeneration, j is equal to 1 by 2. So, 2 will be cancelled, 1 by 2. So, this is the degenerate, 2 states will be splitting S, and this is the 2 states simply, this is the 4 states it splits, because 3 by 2, 2 into 3 by 2, 2 to cancel, 3 plus 1, 4. Okay, so, this is a 2 splits. So, total 4, 2, 6, 7, 8, 9, 10. So, total 10 lines will be comes. Okay. So, this is called total number of spectral terms in D1, D2 lines are nothing but 10 lines. Okay. See, you will draw the finite structure diagram. So, normal Gman effect, it was splitting like that. See, it splits into 2 states. So, 2p 1 by 2, 2p 3 by 2. Okay. This is a p state, and this is the S state is splitting into only one state. So, S is equal to just 2s 1 by 2. Okay. So, the transition is possible from here to here. This is represent D1 line and D2 line. So, remember it. So, in case of anomalous Gman effect, this is placed into any external magnetic field. Okay. So, therefore, and this will be split into 2 lines. Why? Because it is a 2 2. Okay. This will be split into 2 2, and this will be split into, okay, so 2s 1 by 2. This will be split into 2 parts, and this will be split into 4 parts. So, therefore, the total splitting will be in p state, this is a p state, and it will be split into, so that is splitting into 4 parts. Okay. So, this is first, second, third and fourth, and see, now this is the p, right. Now, this p is splitting into 2 parts. Why? Because the degeneracy is a degeneracy is nothing but 2, because 1 by 2 j values is simply put j value here, 2 into 1 by 2, 2 to cancel, 2 plus 2, 2, total 2 lines will be splitting. So, right now this will be splitting into 2 lines, okay, 2 lines. So, right now this is splitting into 2 lines. So, simply write this is nothing but minus 1 by 2 to plus 1 by 2, and this is minus 3 by 2 to minus 1 by 2, 1 by 2, 3 by 2, and this is minus 1 by 2, minus 3 by 2, okay, sorry, minus 1 by 2, plus 1 by 2. So, total lines, okay. So, this is a state and this is a p state only. So, total lines right now it will be splitting into 3 lines, okay. The delta ml, delta mj. So, what is the selection rules here? Also delta mj is equal to 0 plus or minus only 1. So, these are about the selection rules, okay. So, delta mj is equal to 0 plus or minus only. So, you will take this is delta m is minus value here, delta mj is equal to 0 and delta mj is equal to plus 1. So, possible transitions you have to draw on this here. So, 0 0 will be possible when 1 by 2 to 1 by 2, okay, and similarly here 1 by 2 to plus 1 by 2 to, okay. So, only 2 lines, I think 2 lines maybe. So, if you draw the pattern you can understand transitions, you have to place the transitions. So, this is about sodium D1 D2 lines, okay. So, thank you very much. So, tomorrow session I explain Stark effect. So, thank you very much.